Hi, right now I'm going to talk about generating an unstructured grid over a sphere. As you can see here, uh, this is a section of the domain, and you can see the tetrahedral elements and the prism elements in the boundary layer region. You can see, let me zoom in. As you can see, for example, this is a prism cell. Okay, and another point to be mentioned is that the cells in the wake region in downstream of the flow here are much more smaller than the cells in other regions of the domain. This is why this is because in this region the flow is more complicated, and if you want to model it correctly, you need to have a smaller cells. Well, from the beginning, I start a new window of the Gambit program. First, from this geometry tab, and here right click and select sphere, a radius, for example 10. These are all optional. You can change them according to your project, as you can see. After that, here, no, excuse me, here again, select brick and 3 dimensions for this cube, for example, 400, 100, and 100. Apply it, fit the view, okay. Now I translate the sphere to the left or the hexahedral domain to the right. For example, here I select the hexahedral domain, and in this field for x, I put in enter, for example, 100 and apply it by right clicking. Okay, it's good. After this, we need to subtract the sphere from the hexahedral because we are going to model only the flow region, not inside the sphere. Come here, right click, subtract this one in the next field, the sphere, and apply. Okay, and let me show you, for example, the mesh, volume mesh, and we are going to mesh the sphere surface. So in this field, click the sphere surface, and here elements, we need triangular elements, and the size of them, for example, 0.3 or maybe less, 0.2, and apply it. Now let's zoom to see the elements. These are the elements. In order to have a better speed for the program, let me undo this level and have it 0.3. Again, 0.3, triangular elements, apply. Okay, now I want to add boundary layer. Come here, and the window, take it much a little upper, right here click and select faces, The first row is, for example, again, 0.3, and the growth factor here, I do not want it to get larger. You can change it, and the number of rows, for example, 10, and select the sphere surface and confirm. Close this window. And the axis here, the coordinate frame, I want to change the visibility. Click it, and visibility, choose off. Apply it. Okay. Right now, if I come here to the grid in volume grid, and I select all the volume, and just for example select the spacing of, for example 5, and apply it. Wait for the program to complete the process. After that, let's just examine the volume grid and see the elements. Okay, done. We have about 700,000 elements, almost. Select all the types, and in the Z direction, align it. You see, we have the boundary layers here. This is the boundary layer, prism elements, and after that, we have 10 layers because we choose it. So after that, you have the tetrahedral elements, and you see they are all the same size. We want them to be smaller near the sphere and in the wake region, and to be larger far from it. Okay, so let's undo this level, and again I want to show you how to do so. In the last tab, which is tools, select the second one, and here in the type we are going to use a meshed size function. In fact, this is going to determine the size of the elements as as a function of the sources you select. In the Sources tab, select the sphere surface, and in the attachment, select volume, and the main volume you have. And in growth rate, for example, 1.2, and in maximum size, selecting, for example, I determine a number of, for example, 10. Okay, apply it, close the window, again come back to mesh of the volume and select the volume and just apply it, and let's see what's going to be generated. Wait for the program to proceed. Right now we expect the elements be smaller near the sphere and larger far from it, and the maximum size of the elements we would be 10 as we determined in that field. Update it, align the view, come closer. You see, these are smaller, and they grow and they grow and they grow. They get to the size of 10. I think the edges are 10 units, and after that, they do not grow any further because we put a limit for the maximum size. Okay, right now I'm going to uh, do it more completely. I want the elements be smaller in the wake region. Here in this region, I want them to be smaller to capture and have a better resolution of the flow features. Close this, undo that, undo the former um, process, and here come to the geometry, into vertex creation, and let's have a vertex on this on the sphere. First come here in display and select mesh off, apply it, close. The visibility of the mesh is off. Okay, come here and we want a vertex. We want to put a vertex on the sphere, so the radius is 10. If we select x10, that's the point. After that, in the edge, right click, select sweep, select the vertex, and select one of these edges for this field, for example this one, and apply it. You have an edge here. Let's make it meshed. From here, select this, for example, make it, for example, 300 and segments, and here select the first lens, and the first lens, for example, is 1 verse. What's the problem? Oh, excuse me. Select this to be interval count. Again, for example, 300 segments. Come closer, and the first lens is, for example, 0.3. Okay, reverse it. Okay, that's right, and apply it. Again, come to the tools. Here in the mesh, we are going to introduce another source, but the source type is edge. Select the edge, okay, and in the volume, again the main volume, select it, and the growth rate, for example, 1.1, max size, for example, again 10. You can change them if you like. Apply it, close the window, again come back to volume mesh. Select the domain volume and apply. Okay, let's see what's going to be generated after this. We expect these edge segments to take effect on the final result. And we have elements, smaller elements in the wake of the sphere. Okay, that's it. Close it, display the grid, update. Let's see what's doing. Yeah, as you can see, we have a smaller elements here in the wake according to the meshed edge. Let's zoom it. Let's zoom in. We have the boundary layer prism cells here, 10 numbers, and we have the smaller elements in the wake. Okay, that's it. I will talk about boundary conditions and Fluent, CFX, and OpenFOAM practical simulations of this special flow later in the next sessions. Thank you and goodbye.